name again is Michael Watene. I work for HuQAS. Kindly allow me to bring to you to science again. This is about malaria microscopy. So this presentation, the objectives are three. We want to determine whether during this time between 2020 and 2022, our participants were able to satisfy the requirements of detection, species identification, and quantification. So there's one aspect which we do here, which is species stage identification, which I will not tackle. So that is what our objectives are today. Kindly allow me to go to the introduction. Malaria is a public health problem, yes, we know that. And we know how it's transmitted through bites from Anopheles or infected Anopheles mosquitoes. Remember, parasites transmit sporozoites, then what goes into us and now turns into merozoites. And now the cycle goes on, whereby we'll talk about trophozoites, schizoids, and gametocytes, which are the stages of the parasites we'll see in malaria. So incubation period depends on the species, but at least 1 week is enough to ensure that we are able to detect this malaria parasite. We have currently 6 species of malaria parasites. We have PF, which is commonly known by most of us. We have PF, which is commonly known by all of us, or most of us. And then we have PM. We have subspecies of PO, and now the PV and P-NOLC. Malaria diagnosis can be done through various methods. One of them is microscopy, which I will talk about here mostly, but we have others through rapid test kits, QBC, and nucleic acid amplification methods. Like we can get it through those methods I've highlighted there. PCR, real-time PCR, LAMP. I think Mr. Chege has not talked about their LAMP equipment, yes. TB LAMP. It can be able to do that for us as well. So malaria microscopy is the gold standard method for diagnosing malaria. So we have other methods, yes, but this one is the gold standard because it has an advantage whereby we are able to use our thick and thin films to detect and actually speciate the malaria parasites. So we supply the participants with GM-sustained malaria parasite, blood films, both thick and thin films. Our requirements here, what we require to do here is to have a malaria microscopist who is at least has skills and competency in microscopy, yes. Properly working microscope, you have good reagents. Yes, currently we have GM-sustains which are in the field, but they could not be working very well for you. So yesterday we talked about quality control process. So do your due diligence, ensure the reagents are working for you properly. And then, of course, we have to have electricity for you to be able to work with the microscopes. This method is fairly affordable. I've said fairly affordable because you require some cost, of course, but it's within, I think, affordability of many labs, yes. We have advantage of using it because it is, I said, it is able to do the detection. You'll be able to do the speciation, the stage identification, and quantification where necessary. And of course, quite a number of us are familiar with microscopy. So it's a skill which can be nurtured and we can be able to perfect our microscopy skills. Yes, so this program for whatever, or this study which we did, is the quarterly program, whereby we are supplying EQA material to participants 3 times in a year. So these are 9 test events. That is for 2020, 2021, and 2022. So this is a retrospective years study, which we are doing here to gauge whether these participants are able to reproduce what we expect them to give in terms of the results, because these already known cases or known, we have what we call a certificate of analysis. So the study, we are able to have the microscopists do 2,256 slides, where they were supposed to do malaria detection, species identification, quantification, and species stage identification, whereby I sent the last one. I'll shelve a bit for now. What do we mean when we talk about detection? Yes, detection has two aspects. Mostly you find that WHO will talk about only giving you the malaria positive slide, so you're able to pick it as positive. They expect you to pick it as positive, yes, having malaria. But for EQA, we supply both, or we supplied both positive and negative cases, so that these facilities can be able to tell us whether they have malaria or they don't have malaria. They speciate, they quantify where where is required. So for this detection, participants were able to get an acceptable score, an average score. Of course, this is supposed to be an average score of 90%. That is meaning 2,032 slides were able to be picked as correctly as required from our COA. Now, we'll go to some data to see what happened. So, for first test event 2020 and second test event 2020 and that test event 2020, that is how the performance was. The slides were given whereby we had known cases, of course, yes. So that is how the performance was. And this can be able to point. You can see this is the performance pass. The number of participants were 30 here for first test event 2020. In the second test event, we had 53 participants, and this is how the performance was. These two slides were able to get 100%. Then the third event is this one, whereby we had 60 participants. The average score for the whole year was 91%. Let's go to the 2021. This is how the performance was. Yes, still we had 30 participants in the first event, 75 in the second event, and 72 in the third event, whereby the average score at the end of the year was 88%. Then in the year 2022, still the same. We had 5 participants in the first event, 51 in the second event, and 43 in the third test event, whereby the average score at the end of the year was 90%. Now, we go to the second aspect, which is the species identification. So after identifying whether a slide has malaria parasites, the participants were expected to go ahead and tell us which species of malaria parasite is in this slide. So whereby now this depends on the skill of the microscopist to be able to have the characteristics for each species at their fingertips so that they can pick the correct species for each malaria slide. On this, we had 2,256 slides, which was supplied to the participants, yes, but only participants were able to do, or those participants were able to pick on malaria species identification only did 2,212 slides. Whereby in those slides, 1,802 were positive for malaria, different species, yes, and 410 were no malaria parasite slides. This was an average score of 69% as per the performance which we saw between the 2020 to 2022 years. So this is how the data was looking like. So in the first event, 2020, we had 38 participants who reported. So you can look at this and you'll be able to see that some of the participants were not registering all the analytes. You can understand that, because the first event we had 30 participants. So here there's a number of 8 participants who did species identification, yes, only. So 51 for second event and 59 for the third event, whereby the average score was 70%. So and we go to the year 2021. Also, this was an average of 2020, how we distributed the slides, whereby you can see this how the slides were distributed in the first event. This means that we did not have no malaria parasites in the first event here. We do not have PF in the second event here and PO. So the distribution is determined by the allocation for that particular test event. So this is how it was, whereby now looking at this, but the average score here was at 98% when you look at this, yes, for the first test event. No, not the first test event, yes. You can see this one is aggregated, or this the score is given as per the performance at that particular test event. You look at that, Sorry for misguiding you for that. So let's go to the year 2021. Oh, this is just a graph representation of that, yes. Let's go to the year 2021. So the participants who registered for the event in 2021 were 30. In the second event 2021 was 75 and 76 for the third event 2021. The average score was 71%. This is how the data or the distribution of the slides was done from the first event to the third event. So where I've left a blank means that that particular test event did not allocate that slide. Like PM was not given the second event. We don't have PO and PF combination of PF, PM, and PF given in the third event, of course. Okay, PF we gave it here, yes. But I was doing this so that you can be able to pick from every test event how we allocated the slides. This is how graphically the data looked like. Now in 2022, we still had the same. So this is how data, how we distribute the slides as per the number of participants who registered, and the average score in 2022 was 68% for species identification. So this is the summary of how the slides were allocated. And that is the graph summary of the data. Now, observations which we made during, for species identification, of course, and detection here is, you can see participants were easy to pick PF because it's quite commonly known by many of us. But you can see the other parasites were quite difficult for the participants to pick, especially PM and PO. You can see that during those 3 events or 3 years, we did not have PV. Yeah, so we don't looked at the PF, PM, and PO. But generally, we need to look at how this here, the detection, yes. But so we need to see the competency of the participants in that aspect of species identification. Yes, the patient may go home with the correct medication, but of course, the aspect of speciation is very important in terms of treatment of the patient. So let's go to the that aspect, which is quantification. Now, quantification is done to determine a few aspects here, which one of them is severity of the infection, which is very important. And when the patient is on treatment and coming back for follow-up, we usually use still microscopy to determine the response to treatment. Again, those who are doing clinical drug trials like Emory, they require this, and actually maybe depending on the SOP, maybe they will do quantification for all the species. But there's an aspect we will also discuss here about EQA, which will, I think, is advised actually at this point here. According to WHO, they actually indicate that you should do species identification. Once you do species identification for PF, you're supposed to do quantification. But depending on your SOP, kindly do what is necessary at your facility. But that is what we do, of course, in our EQA program. Actually, when you do the validation of the slides and cross-check of microscopies, the quantification aspect is very much looked at. Now, this is how we do it. We do quantification using both the thick and thin film. The aspects of the number or the the number or the parastemia is very important for us to be able to pick which method we are going to use. So for low parastemia, we use thick films, but for high parastemia, we use thin films. We'll see how we do the calculations. So for these, 571 slides were reported as having PF, but only 544 were able to be quantified by the participants. Of these, 113 were able to be picked as correctly reported in terms of the expected quantification values, which is a 21% score for the 3 years. This is how the data looked like, yes. You can see here. There were 19 participants, only 5, and 44 for the second event and 51 for the third event. The average score was 12%. For 2021, because that's how the data looked like, 27 participants, 69 participants, and 55. Then the average score was 34%. There was good performance here in this year 2020. So this should be 2021. Sorry, corrections please there. 2021. Then in 2022, we had a drop again. The average score was 11%. So this is how we do the calculations. Once you use the thick film, the calculations you do them, you do calculate, that is, you do count parasites against WBCs. So you count the number of parasites against the WBCs up to 200 WBCs. But if there are fewer than 10 parasites at the time you're getting to 200, increase the counts to actually make sure that your data is correct, or in other words, you're increasing your accuracy. For the thin films, you count infected red blood cells against total red blood cells, but you count up to 5,000 red blood cells, up to 5,000 red blood cells. So you can do your average for your counts for each field. Then you can know, like, if you're having 400 red blood cells per field, you can get to know, like, you're counting how many fields to get to 5,000. Around 11 to 12 fields. Are you together? So that's how you can do it to make it easier for you. And then for WBC, when you're using WBCs or the thick film, you multiply by 8,000 WBCs per microliter of blood. And for where you're using thin film, you multiply with 5 million RBCs per microliter of blood. Hope this is clear. So this is how you multiply it. But if you're doing it in your facility, kindly use the CBC report which you have. So use your WBC count if you've done the WBC count for your patient, or the RBC count if you've done the RBC count for your patient. This is for a matter of reporting in terms of EQA. Okay. Now, so this is what we observed. Yes, in the first year, which is 2020, the average detection score was 91%, whereby the second was 88% and 9%, average of 90%. Yes. So the criteria of WHO says that you are supposed to get a 90% for you to be a level 1. Yes, but we can see detection is doing very well at 91% average score. But speciation really gave us some kind of a headache. Yes. Because the average score at the end of the 3 years was 68.7%. Then quantification was least performed at an average score of 19%. But the acceptable score, yes, is supposed to be quantification 50%. That's very low, eh? It's like those people who are doing sciences. They have a pass mark of 40%. But those who are doing some other, you get it, eh? So quantification is not easy. That's why the WHO says for you to be able to qualify to be a level 1, you have to have an average quantification score of 50%. So what is our conclusion for this? Yeah, of course, I think I discussed that. No, this is supposed to be conclusion, sorry. So there is need to strengthen the malaria diagnosis by imparting malaria microscopy skills and competencies to our malaria microscopists. Not only those who are participating in this program, but I think this is a representation of what could be happening on the ground there. So what can we do? It's only to strengthen the skill to ensure the microscopists are able to pick the malaria parasites, species them where is necessary, and actually do quantification when necessary. How can we do that? Regular microscopy trainings, whereby they say actually, even for WHO, they say we rust after every 3 years. So after every 3 years, you go and defend your level 1 or your level 2. Those who support in that kind of an exercise, they know very well. So an expectation is we rust even in our practice. So we need to get refresher trainings now and then. We can also do that by those who go around, like our level 1, level 2s in the government facilities. They do a lot of cross-checking for the malaria microscopies and on-site supervisions. But internally, if we have competent malaria microscopists, we can do our CMEs and ensure we somehow increase the competency and skills of our malaria microscopists. Now, I have mentioned about this every 3 years. Now, if you are not participating in malaria microscopy, I mean in EQA for malaria microscopy, you may be missing an aspect of maybe what we call an evaluation of oneself, because when you do like participate in this program, as a facility as you are evaluated, but you see personally I'm the one doing this kind of malaria microscopy reporting, so I'm able to also to evaluate myself and get to know where I am in terms of my skills. Thank you very much for listening to me. That's the end of my presentation.